every organization has endpoints, laptops, workstations, and all that. So, and every organization needs to manage those. So most organizations, well, actually all organizations I know, procure some kind of management software to do all that. And that's really powerful software. You can install patches, you can set password policies maybe, run arbitrary scripts, take over the endpoint. So it's crucial that this kind of solution is secure. And we've seen problems in the past, most notably probably SolarWinds a couple of years ago. That basically, there was a supply chain attack, and that caused lots of trouble because suddenly an attacker is in the heart of your system. But there's more of those. Today, we're going to talk about Ivanti EPM software and the SQL injection attack in that platform that happened. It's a completely different attack than SolarWinds, for example, but it's similar in its consequences. The heart of your management system is being compromised. So we're going to talk about today. Welcome to Threat Talks. This is Threat Talk, the deep dive. My name is Leeuw-Jan Koning, and from the Security Operations Center floor at Ontoit, I welcome you. Let's get onto it.
Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity.
I'm joined here today by my two guests, Luca Cipriano. He's a threat intel specialist at Ontoit, and we have Rob Maas, who is a field CTO at Ontoit. And we're going to go into the weeds of this attack. Very powerful software. Luca, maybe let's start at the beginning. What does an attacker need as a prereq, basically, to go start on this attack?
First thing the attacker needs for this attack is network access. So this is a vulnerability on the Ivanti EPM server, and so the attacker needs to be able to reach the server. It's a SQL injection, so the attacker will have to send the SQL.
Okay. So it's a bit later in the attack chain, basically. You're already there, and then let's see how terrible things can happen.
Yes.
Okay. Rob, we talked about gaining access to networks a couple of times. I mean, how do we generally defend these kind of things?
Yeah, there are a couple of ways. But let's stick to the networking part. An attacker needs to come in, so have a host or a server or a client, maybe a Raspberry Pi, whatever, to come into the network. And then the first defense is, can we block access to Ivanti in this case? So an attacker is in. We already discussed a lot of vulnerabilities, how you can gain into the network. But now the attacker, once he's in, he needs to access the EPM. So let's block that. Let's make sure it's being blocked.
Yeah, so basically what you're saying, getting in, I mean, that's child's play for Luca, right? I mean, he's in easy. But then the next step.
Exactly. The next step is basically he wants to access the EPM. And if again, segmentation is coming back a lot. But if you segmented the network correctly, so hopefully the EPM is in a different segment, endpoint management network, which only allows access to certain systems and users, very specific, then it's pretty hard for Luca to access that segment and to execute his next step.
I'm always the bad guy here. Huh?
Or you pretend.
Yeah. Well, I think I just would like to add, because maybe some people don't know what is EPM, Ivanti. So, well, the EPM is basically, it's an endpoint management solution from Ivanti. This was previously known with the name Landesk Management Suite. Not so sweet. Basically, it's an endpoint management solution which is used like to help IT professional to manage their network. You can use it, for example, for device discovery and inventory in your network, but also to distribute software to every endpoint on your network, but also patches. And it has also like a remote control and support capabilities. So you can imagine that as an attacker, I mean, if I have access to this, bingo, like I can just start to install my backdoors and my malicious softwares everywhere in the network, for example.
You are the bad guy.
Attacker bingo, yeah, the joy you have in your
bingo,
eyes. Yeah.
So I mean, it's really valuable for an attacker.
Key to the kingdom, basically. And this is something that you cannot solve with segmentation, right? I mean, there's lots of course, it will make it less severe, but in the end, everybody needs to be able to.
Well, the challenge is that endpoints needs to communicate with it because it's an endpoint management system, so that makes it a bit more challenging, of course. Yeah.
Okay, so then now I am the attacker, or
Luca is.
or Luca. Yeah. So what would you do, Luca? You have this local access and then a SQL injection. How?
Yes.
So what is this SQL or SQL?
SQL
database.
Yes. So basically, SQL is a structured query language, which is a programming language that is used to interact with relational database. Relational database are basically databases that have tables that basically contain data that are related one another within different tables. And SQL is basically the language that you use to manipulate that data, but also like to read, write, delete that kind of data.
And by you mean in this case the
everybody
solution?
that uses it, like for example, the solution or everybody that has the database or the application that needs to access the database for any reason.
Yeah, so in this example, this breach, the database is actually queried by the EPM, the server, right? Probably.
The database is in the EPM, and the attacker is sending the SQL injection to the EPM. But
the only guy supposed to talk to the database is the solution itself, is the EPM solution.
Yes, I believe so. I'm not 100% sure on
you didn't
how
design the system.
Yeah, I didn't design the system, but I believe so.
So typically how it works. Yeah.
Yeah.
Okay.
So, this specific threat is about SQL injection. What is an SQL injection? So basically, an SQL injection is an attack that target the data that is stored in that database by injecting malicious SQL code to the database. For example, one easy example, like you have a login page where you need to put your username and password to log in. And of course, the username and the password are stored in a relational database because the username needs to be correlated to the hash value of the password. And for example, you put the username admin, and then you need to add the password. If the SQL input is not sanitized, it could lead to SQL injection. And for example, on the password, you could put like quote or 1 = 1. So you can put and then close the quote. And since 1 = 1 is always true, then basically it will tell to the database the username admin and the password nothing, or if 1 is = 1, then I'm allowed to log in.
Yeah, so certainly this particular command, instead of responding to a username and password that's been checked and returning only a row if it's a valid password, it will now always return.
Because it will be always true.
So
it will just allow you to log in. Exactly. You bypass authentication. This is a really simple example of SQL injection.
Okay. And why is this possible? I mean, Rob, is this a flaw in software? Is this easy to patch, or how?
Yeah. So in this case, it is easy to patch. The researcher that found out about this issue, that basically the SQL was not properly handled and checked for SQL injections, he did a responsible disclosure, meaning he told, in this case, Ivanti, hey, I found a bug, vulnerability in your systems. You should patch it. And he did that in a responsible way, so without telling the whole world, hey, I found this. He gave Ivanti the time to patch it, and they come out with a patch and a disclosure, hey, this is what we have found, you should patch immediately because it's quite severe. We know the researcher did a responsible disclosure, but maybe other people also know about this SQL injection possibility. So patching is one of the things to prevent this attack. The other option that you might have, if there's a IPS in between, so an intrusion protection system that can sometimes detect the SQL injections and then block traffic, saying, hey, this looks like an SQL injection, I block it, and then hopefully prevent the attack from a successful injection on the EPM in this case.
You need to decrypt the traffic, I think.
Yeah, if it is encrypted, it doesn't work, so it should be readable for the IPS. Yeah.
Okay.
Yeah. So the next step of this attack basically is, the attacker send this injection, and basically this SQL injection bypasses authentication. So the attacker does not need authentication to run this code on the database. And what it can do, of course, it depends on the injection. And one thing to note is that they did not disclose the injection specifically. But what you can do is like read, write, delete data, or all these kind of things normally with the injection. The extra thing is like that if the EPM server uses SQL Express, which is a light version of SQL, then the attacker can also run remote code. So it has a remote code execution on the server, which is, as you can imagine, really bad, of course, because then can have really access to the server. But despite that, anyway, the attacker will be able, even if SQL Express is not used, to fully take over any device that is enrolled with the EPM server. So, well, basically has an access and entry point for any device that communicates with the server.
Yeah, so if all the prevention we talked about before, segmenting the network didn't work, or you didn't apply it, and then IPS isn't there, then we got to assume that this may happen at some point. If it's not this vulnerability or this solution, then maybe another solution, different attack. And then what? I mean, then an attacker has access, can probably install malware the proper way, basically. Yeah?
Yes.
Yeah.
And then have access to any endpoint that is enrolled, and then from there, well, it depends on the objective of the hacker. Can deploy ransomware, it can start to steal data, or whatever the reason is why the hacker is in the network. It depends on the.
I can see why you are so happy thinking of having this kind of access.
Yeah, and the potential reach is quite large.
Yeah, it is.
It's not a company with only 5 endpoints that uses an endpoint manager. Typically, companies that have over 100 or even thousands endpoints.
Indeed.
So your reach is very big.
So we should assume that we may have to defend ourselves from our own management solution then. Mm-hmm. So what kind of things were we thinking about, Rob?
Yeah, so we have Ivanti is endpoint management, but we also have endpoint protection tools like EDR solutions. They typically can detect if they are installed on an endpoint if strange behavior occurs, processes that should not be run, privileged access that's not typically given, all kinds of kind of malicious activity. It can detect that and then also stop it, and then of course give an alert to the SOC, and then the SOC can investigate. Hey, what's going on here? This should not happen. So an EDR can help to see if Luca in this case is installing malware on the endpoints.
Yeah, it's a starting point. So there's lots of chances to detect what the attacker.
It depends on how good the attacker is. Yeah. Like nowadays, a lot of attackers, they try to use leaving off the lands or like software that are already used by network admin, and they can blend in with legitimate traffic. So it might not be so straightforward to find it out. But of course, like as Rob mentioned, the EDR that have behavioral analysis, they could alert eventually if behavior that deviates from the norm is detected, and it's a good point. But it depends always on how skilled is the attacker.
Yeah, and make sure that any endpoint that's compromised cannot access everything immediately.
Yes,
that's always a good
segmentation.
idea.
That's always,
Okay,
of course.
Gentlemen, thank you very much for your insights, and hope to see you next time. To our viewers, thank you very much for tuning in, and see you next time at Threat Talks.
Thank you for listening to Threat Talks, a podcast by Onto It Cybersecurity and M6. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.